Hello everyone, welcome to this session. Our chapter is waves. So far in our previous video, we covered up discussing about the various behaviors of these waves. So let's move on to the other part. Today we'll see the application of all the behaviors of waves. We said that the behaviors they include as the reflection, diffraction, and the interference of waves. So we'll see the application of all of these, but also there's also deflection there. I mean reflection. So all four behaviors of waves, reflection, reflection, diffraction, and interference of waves in our daily life. So we'll start discussing each one of them, starting with the application of reflection of waves. The following are just some of them. The first one, that the phenomenon of the reflection of sound, the one that is used just to determine the distance between the two objects. For example, depth of the seabed, depth of the cave, and the width of the wave. So when we're talking about the reflection of waves in terms of sound waves, we see that the phenomenon of this reflection of light is very useful in determining the distance between two objects. For example, maybe when you're talking about the depth of the seabed, we will find the concept of reflection of the sound waves important also in terms of the depth of the cave. And also another example is the width of the valley. So these are just there as to determine the distance between the 2 points. So the type of sound used must be ultrasound. So the ultrasound is the one that is there just to determine the distance between these two objects, or just the distance between 2 points. The other application of reflection of waves in sonar, that is the sound in navigation and ranging. So reflection of waves in terms of the sound waves can be useful in this sound in navigation and ranging, also known as the sonar. The sonar is the one that is used to detect the underwater objects, coral or fishes, or just to determine the depth of the water by means of an echo. So the use of the sonar is very useful, especially in underwater, just to determine the depth of the water in terms of, or just means of an echo. So also in terms of any objects that can be detected underwater. Sonic equipment, simply they emit a high frequency sound signal which is reflected by the object in the water. So that's how it works, and the reflected sound is received by the sonar receiver. Now the time taken for the echo to return is used to determine the distance of the object below the water surface. So that's how sonar is useful, as help to determine the depth within or just under the water surface. Also, sonar waves of high frequency is used because it simply possesses more energy, high penetration power, and it can travel further through water. So why do we use the sonar waves? Is because uh, uh, it possesses more energy, high penetration power, and it can travel further through the water. Moving on, the other application, reflection of light waves is used in the design of mirrors. So this application of light waves, it is very useful in designing of various mirrors. Also, the detection of cracks in metals. So reflection can be used to detect the cracks in metals. Also, determination of frequency of the ACs. So those all are just some of the applications of reflection of waves in our daily life. Moving on, let's see the applications of the reflection. So this is the other behavior of the waves. So let's see the application of this. The applications of the diffraction. The first one, that reflection has many applications in optics and technology. So reflection is useful, especially in optics and technology. For example, in terms of such as a lens uses this concept of reflection just to form an image of an object for many different purposes, such as magnification. Uh, the other application of refraction, a prism also uses the refraction to form a spectrum of colors from an incident beam of light. So the concept of refraction is useful in prisms just to form a spectrum of colors from an incident beam of light. Also, refraction also plays an important role in the formation of mirage and other optical illusions. So that's the other application of this refraction in our daily life. Moving on, applications of the interference of the waves. Now, interference is applied when creating holograms. So this is the first use of interference useful in creating these holograms. A hologram, simply this is the photograph of an interference pattern which is able to produce a three-dimensional image when it's suitably illuminated. So that's the meaning, or just the definition of the hologram. It's just a photograph of an interference pattern which is just being able to produce a three-dimensional image, a 3D image, when it's suitably illuminated. So that's the meaning of the hologram. So interferences are useful in creating these holograms. The other use, interference, especially this destructive interference, is used in noise reduction systems such as the earphones, the earbuds, etc. Those earbuds cancelling noise ones are the ones that uses this concept of destructive interference. What happens is that the system captures the sound from the environment and uses the computer technology to produce a second sound wave, which just leads to reduction in the loudness of the noise. The other application of interference, concert halls and auditoriums are usually designed in such a way just to reduce the amount of destructive interferences. So the interference of waves is useful in constructing these concert halls and auditoriums. Usually the holes and the ceiling made in such a way that they absorb rather than reflect sound. So the walls in the concert halls and the auditoriums are just made in a way that they absorb the sound within and not just reflect the sound. Let's see the application of wave diffraction. The following are just some of them. The diffraction, it is applied in diffraction grafting. Diffraction grafting, this is an optical device that consists of not one but many thousands of apertures. So this is the a device that just uses this concept of diffraction. So a diffracting grafting, this is just an optical device that it consists just not one but many thousands of the apertures. A spectra produced by a diffraction graftings are extremely useful in applications from studying the structure of the atoms and the molecules to investigating the composition of the stars. So that's the uses of the spectra that is produced by these diffraction graftings. The other application of wave diffraction in X-ray diffraction. X-rays are light waves that have very short wavelength. So when they irradiate a solid crystal material, they are diffracted by the atoms in the crystal. So X-ray diffraction utilizes an instrument called a diffractometer just to produce diffraction patterns that can be compared with those of known crystals just to determine the structure of a new material. So that's how this wave diffraction is very useful in terms of these X-rays that can be very useful in hospitals. The other application of wave diffraction, the holograph. The holograph, this is the science and practice of making the holograms. We've already seen the meaning of the holograms. So normally a hologram is just a photograph recording of a light field rather than of an image formed by lens, and it is used to display a full 3D this 3D image, meaning three-dimensional image of holographed subject, which is seen without the aid of special glasses or other intermediate optics. So that's how normally how it is for the hologram. So an illuminating laser beam is diffracted at specific angles in accordance with the Black's law on the surface of the hologram, making it possible for an observer to see a 3D image. So that's how this wave diffraction is useful in holographs. So that's all I have for this session. That's clear, everyone. Thank you for listening. We've seen the various application of all the behaviors of the waves. We've seen the applications of refraction, interference, and the diffraction. So that's all clear, and thank you.